So today we're going to be figuring out how to solve quadratics using the AC method. X squared plus 2x plus 1. So the AC method is like AC, right? So it's A times C. So you're going to say A is technically, there's like a 1 here that you can't see. It's not going to be 0 or else this wouldn't exist. So it's going to be 1x, so A equals 1. So A equals 1. B equals 2 and C equals 1. So you're going to take A and C and you're going to multiply them together. So 1 times 1 equals 1. And then you're going to take this and you're going to see all the factors of 1. First you have 1 and 1, and then you have negative 1 and negative 1. And those are all the factors of 1. So then you're going to see the sum of these. So I'm going to say 1 plus 1 and then minus 1 plus minus 1. So this would equal 2, and this would equal negative 2. And B equals 2. And you want to see which one of these gets you the B value. And as you can see, 1 and 1 gives you the B value, which is 2. So this is the one that we're going to be using. So then we're going to rewrite this equation as x squared, and then we're going to split up B using these two specifically. So you're going to say plus 1x plus 1x plus 1. So these two stay the same, but we just split a B using factors of A times C. And after that, you're gonna factor these kind of. So you're gonna take this and then this, and then you're gonna factor each one. So I'm gonna start off with factoring this one. We can factor out x. So you get x plus 1. So this would make, if you multiply this out, you get x squared plus x, which is equal to 1x. And then here, you can see that you can factor out 1. So you take 1 and then x plus 1. So now you see that these two in the parentheses are the same. So we're going to combine them into this one. And then we're going to take these two. So this is positive 1. So technically there should be a plus there because there's no negative sign. So this would be positive 1. If you did say this was negative 1 and you multiply out, it would not equal this. It has to be positive 1. So then you take this x and this 1, and you put it into parentheses 2. So you see this is the equation. And the AC method, we're solving for the zeros or roots of the quadratic equation. So technically this is all equal to 0. So we can set this equal to 0. X plus 1 in the parentheses is being multiplied by x plus 1 in this parentheses. If either one of these equals 0, then the whole equation will equal 0. So we just need to get one of these to equal 0 and we'll be good. So we will set each one to 0. So this one will become x plus 1 equals 0, and then you subtract 1 from both sides, cancel out 1, and then you get x equals negative 1. You do the same for this side, so x plus 1 equals 0, and you subtract 1, x equals negative 1. And now you can see we have found the roots, and the roots are actually the same, which I'm not going to try to go into too much detail here, but basically that means x equals negative 1 has a multiplicity of 2, and that basically means that on a graph when x equals negative 1, since it's even, it will bounce off. And if it were odd, like if there's just one negative 1, then we obviously need another root because this is quadratic. The degree is 2, which means that we have 2 roots. So this one we have 2. They're just the same, which means that it bounces off. But if we only had one of these, then the multiplicity would be 1, and instead of bouncing off, it would go through, and then we'd have like another root somewhere on the graph, and it'd like go up through the other root. But since it's at negative 1, it just bounces off negative 1 because it has a multiplicity of 2, which is even. And we know that it goes up because the coefficient is positive. If it's positive, then it will go up. If it's negative, it will go down. Anyways, we can confirm this because if we want to solve for vertex, we know the equation for vertex. The vertex is hk, and we know how to solve for h. The equation for h is negative b over 2a. And so using this, we can plug in 2 for b, so negative 2 over 2 times 1. And that gives us negative 2 over 2, which equals negative 1. And that lines up with this because the vertex is at negative 1. So we get negative 1k, and to find k, we just plug in negative 1 because this is basically x for the vertex. So you just plug in negative 1 back into this equation. So then you get 1 times negative 1 squared plus 2 times negative 1 plus 1. And then here you can solve negative 1 squared is 1 because -1 times -1 is 1, and then 1 times 1 is 1. So 1 minus 2 plus 1, and that will give you 0 equals 0. So the vertex is at -1, 0, and that makes sense because we know the 0 is at -1, and since this is 0, it's when y equals 0. If a equals 1, if a equals 1, the roots or zeros/zeros will be -1 times a factor, like, okay, let's say correct because there can be multiple, correct factor of AC. And this is true because we see 1 and 1. If we multiply each one by -1, we get the roots -1 and -1, and that makes sense because we solve here. But that does not work if a does not equal 1. So for example, for the equation, I'll erase it. You can pause if you want to take a picture or something. So let's see. We're gonna just erase this part. Okay, so if the equation is 3x squared minus 5x plus 2, for example, a does not equal 1, but you can still use the AC method. So 3 times 2, because this is A, this is B, this is C, 3 times 2 is 6. And you can see 6 would be like 6 times 1, like 6, -1, blah, 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 or more. And then you get -3 and -2. And you see -3 and -2 will get you -5 if you add them together, because -3 plus -2 is equal to -5. And when you multiply these together, you get +6, which is what you get when you multiply A and C. So that makes sense. So you just use this. You say 3x squared minus 3x minus 2x plus 2. And then you can factor this. So here you get, what's 3x, and then you get x minus 1. And then here you can factor out -2, you get x minus 1. So then these two are the same, so you can put these in parentheses by itself again, so you get x minus 1, and you can put this in parentheses, 3x minus 2, and then you set this equal to 0, and so you set each equation equal to 0. If this x minus 1 equals 0, then you end up getting x equals 1, and if you set 3x minus 2 equals 0, you end up with, if you plus 2, cancel this out, and then you will end up with x equals 2 over 3. If you like divide by 3 and stuff. Since a does not equal 1, this trick does not work, but if a does equal 1, this trick will work. Like, I'm pretty sure, I'm not sure if it's like confirmed, I just like figured it out. But like all the times it has worked. You can just use this if you solve for it and then you see a equals 1 and you're like, oh wait, it's the opposite, then that's a way of checking your work, I guess. But yeah, this is how you use the AC method. Okay, so I'm back. I really quickly wanted to mention, because I was rewatching the footage, whatever, this looks kind of confusing, like how we get from here to here. So I just want to explain this again. So basically, when you're like multiplying polynomials, like this is kind of a review. Like I know some use the box method. I personally don't. I just like multiply across, like how you normally distribute. So when I see this, I see like 3x minus 2 times x minus 1. Oh, that was not x minus 1. So I see this, right? And so basically first you like multiply 3x to like both of these. So when you're multiplying this, you get like 3x times x minus 1. And then here is -2 minus 2 x minus 1. Because like first you distribute this one and then you like distribute the bottom one. And you're not like multiplying this by this, 3x squared minus 3x minus 2x plus 2, if you actually like distribute it out and stuff. And you're not multiplying this by -2 plus x plus 2. You're just combining the like terms, which is why like it's separated by this. And here I can see it's kind of confusing, but like just imagine there's a plus sign, because that's basically how I see it, because you're multiplying it out, and that's why we can rewrite this into this, and this one's just easier to see. You just set each one to 0.